Have you ever really stopped to think about what's happening when you look in the mirror? I mean, really think about it? It's so much more than just a reflection. Today, we're going to follow a single ray of light on its amazing journey to see how it works. And you'll see it's all about some really elegant physics. And we can start with a question you've probably seen 1,000 times, but maybe never asked. Why on earth does the inside of a spoon flip your reflection upside down, but then the back of it shows you right side up? Believe it or not, the answer to that simple, everyday question unlocks everything we need to know about how mirrors work. It all boils down to one incredibly simple principle. When a ray of light hits something, it doesn't just stop, it bounces off. And that simple act of bouncing back is what we call reflection. It's the absolute foundation for everything we're about to see. But here's the really incredible part: how ridiculously precise this bounce is. Light isn't messy, it's a total perfectionist. It follows this one strict rule called the law of reflection. Whatever angle it comes in at, it leaves at the exact same angle. It's perfectly balanced every single time. Okay, so what happens when you get millions of these perfectly bouncing light rays all hitting a perfectly flat surface, like, say, your bathroom mirror? Well, they all bounce back in a super organized parallel way. They basically keep the image they're carrying perfectly intact. This is where the magic really starts. And the result? Well, it's that face you see every morning. It's the same size as you, it looks like it's just as far behind the mirror as you are in front of it, and it has that weird little quirk where if you raise your left hand, your reflection raises its right. But here's the big secret: that person in the mirror isn't actually there. It's what physicists call a virtual image. See, the light rays bouncing off the mirror don't actually come together to form a picture behind it. Instead, your brain is so smart that it traces those rays backward to a point where they look like they're coming from. It's a brilliant optical illusion, a kind of light ghost that's built entirely inside your mind. All right, so flat mirrors are one thing. They're straightforward. But what happens when we start to bend the rules? By literally bending the mirror. As soon as that surface isn't flat, that perfect law of reflection starts to create some truly wild, mind-bending effects. And really, this shows us the two main types of curved mirrors. You've got your concave mirror, which curves inward, like a cave, and it actually gathers light, focusing it down to a single point. And then you have the convex mirror, which bulges outward, like a hill, and it does the exact opposite. It scatters the light, spreading it all out. Now, that cave-like concave mirror, it's a little tricky. It's almost like it has a dual personality. And the reflection that you see depends entirely on where you are standing in relation to it. So, if you're standing far away from a concave mirror, the light rays actually cross over in front of it, which creates an image that's flipped upside down. Physicists call this a real image because you could literally put a piece of paper there and project the image onto it. But get super close, and suddenly your reflection flips right side up and gets way bigger. That's the secret behind every good makeup mirror. Now, the convex hill mirror? Oh, it's so much simpler. No split personality here, no drama. It treats everything it reflects the exact same way, every single time, doesn't matter how close or far you are. So the key thing to remember is that a convex mirror will always give you an image that is upright, smaller than the real object, and virtual, just like the one in a flat mirror. It basically shrinks the world down, but keeps everything right side up. And that brings us full circle, right back to our spoon. When you look into the bowl of the spoon, you're looking at a concave mirror. And since you're holding it a decent distance from your face, it flips you upside down. Then, when you flip it over, you're looking at a convex mirror, which always shows you a smaller, upright version of yourself. Mystery solved. And of course, we use these principles every single day. That magnifying power of a concave mirror when you're up close, that's perfect for shaving mirrors or for the little tool a dentist loses to get a really good look at your teeth. And the convex mirror's talent for shrinking the world to give you a wider view? Well, that's absolutely essential for security mirrors in stores, or for your car's side view mirror. It gives you a much bigger field of vision so you can see what's coming up next to you. So, you see, from a simple kitchen spoon to the mirrors that keep us safe on the road, it all comes down to the beautifully simple physics of light. The next time you catch your reflection, remember, you're not just seeing yourself. You're seeing this amazing dance of angles and perception. Which kind of leaves us with one final thought. When we bend a mirror, are we just bending light? Or are we bending our very perspective on the world?